All right, algebra, this is the last day, day 3 of our semester packet. Make sure as soon as we're done with this video that you have all of your information filled out for this packet, any formulas that you need, anything like that, because you will not have time to fill that in if you come to test day and you don't have it done. So make sure that you have that done. We only have, I think, 11 problems today. We're going 29 through the end, starting with the trig section. And so here we go. Find the value of sine, cosine, and tangent functions for theta. So we're going to go sine of theta equals, and we have a fraction, so we're trying to figure out what the fraction is. Cosine theta equals whatever, and then tangent of theta equals. And when we do this, here's my angle theta, so we have to identify the opposite, hypotenuse, adjacent. But when we're doing all three trig functions, we do have to know what this side is. And we can figure that out by using the Pythagorean theorem because this is a right triangle. So let's call this side X. We know that side C has to be the longest side, so that's going to be my 30. And so let's do like 24 squared plus x squared equals 30 squared, okay? 24 squared, no, 576. I wanted to say 676, but 576 plus x squared equals 30 squared is 900. And then we're going to subtract the 576. And that is 324 equals x squared. And then we would take the square root to figure out what x is. And the square root of 324 is, whoa, the square root of 324 is 18. It comes out perfect, okay? So this side is going to be 18, okay? Now before we start doing our opposite, hypotenuse, adjacent stuff, let's look at our three numbers that we have and figure out, like, can we reduce those? Because I'd rather reduce them here instead of reducing all three of these fractions. So 30, 18, and 24, I think 6 goes into all of them. So 30 divided by 6 is 5, 18 divided by 6 is 3, and 24 divided by 6 is 4. This is a 3, 4, 5 perfect right triangle, okay? All right, then let's go through. If we're looking at this angle, 3 is going to be the opposite, 5 is the hypotenuse, 4 is the adjacent side. So if you need to write this in somewhere, I would put SOHCAHTOA on your sheet. And sine is OH, opposite hypotenuse. So opposite is 3, hypotenuse is 5, so it's 3 over 5, okay? Adjacent is AH, A is 4, H is 5, so cosine is 4/5. And then tangent is opposite adjacent, so 3 over 4. And then that's all you have to do for those, okay? Just sine, cosine, and tangent, all right? Let's move on. If you need to pause at any point in time, go ahead and do that, but try to keep up so you're not pausing this video a whole bunch for everybody else. 30 is, we're going to be using our trig functions again to solve for this x because they give us 64, but you only have to use one of the trig functions. You have to decide which one you're going to use. So if they give us 64, x is the opposite side, and 11 is adjacent to 64. This is the hypotenuse, but we're not using the hypotenuse because they don't give us anything. So we need O and A, which is going to be tangent. Okay, tangent is TOA, and tangent of 64 equals opposite over adjacent is x over 11. Then to get that x by itself, I'm going to multiply the 11 over to the other side, and then all you have to do is take 11 times tangent of 64. Please practice typing that into your calculator, because if you end up not getting the same answer as what we got, you probably typed it in right, but you might be in a different setting, like it's called radians on your calculator. So you might be in radians and not in degrees. So make sure you get 22.6 when you type that in. Otherwise, I need to fix something. So remind me on Monday or Tuesday. You guys will take this test on Monday. 6th and 8th period, take this test on Monday. So remind me Monday and I will fix that setting on your calculator, okay? 31 is radians versus degrees. So if your calculator's in radians, you didn't get the right answer on the last one. We're rewriting 75 degrees in terms of radians. I'm gonna make that into a fraction, okay? And we talked about how like 180 degrees is equivalent to pi. like 180 degrees, that we call that pi as a radian measure. So this is a degree and this is a radian measure, okay? So when we're converting, we multiply by either pi over 180 or 180 over pi, and it just depends on what we're given. So here we're given 75 degrees. So I want 180 degrees to be on the bottom, so I can cancel those degree symbols out, okay? And then from there, I just reduce, okay? The thing that you want to make sure is that you have no decimals in your answer, okay? We're just going to reduce it down as far as we can and get a fraction, all right? So 75 and 180, I know that I can divide by, let's say, 5. 75 divided by 5 is 15, and 180 divided by 5 is 36. 15 and 36. Okay, then I guess 15 and 36 can be reduced more as well. So let's divide by 3. 15 divided by 3 is 5, and 36 divided by 3 is 12. So I just did a double reduce, and we have 5 pi over 12. That should be a 12. 5 pi over 12, and that is what 75 degrees is in terms of radians, okay? Now if we're going the other direction, we're going radians to degrees. It's the same process, except this time we multiply by 180 degrees over pi. And when I do that, the pi's cancel, okay? And then all I have to do is reduce. So I look at 4 and 180, and I think 4 goes into 180. 180 divided by 4 is 45. Degrees. So on the top, I take 3 times 45, which is, I think, 135. Yep, 135. And on the bottom, I just have 1, so I really don't have to put anything. It's just 135 degrees. Okay? All right. If you need to, pause, but I'm going to keep moving on. 33. When we're talking about coterminal angles, coterminal means same stopping place or same ending spot, okay? So 590 degrees is more than one full circle around. Like 590, this would be 360. 590 is going to be, let's see, I don't know, more than one full circle. And to find a coterminal angle, I either add 360 or subtract 360. So in this case, they don't specify which one you do, so you can add, subtract, it doesn't matter. I'm going to subtract 360 just to make this smaller. So if I do that, that is 230 degrees. So 230 would be the same thing as 590, okay? Now you could subtract again, or you could add. I will take multiple answers on this question because it doesn't, I don't specify which direction you're going. So you can either add 360, subtract 360. You can add it multiple times. You could give me like a 1,000,000 degree angle if you want to, as long as it's coterminal with 590, I don't care, all right? So many different answers on that one, on 33. 34, find the exact value. This one's a little bit of work, okay? Find the exact value of the 6 trig functions of theta. All right, let's write those out to start with. The 6 trig functions are sine of theta, cosine of theta, tangent of theta, and those are the main 3. And then after that, we have cosecant, which goes with sine. We have secant, which goes with cosine, and cotangent, that goes with tangent, okay? So we have those 6 trig functions, okay? And then they say what we're going to go off of is -3 and 4, okay? So if I have a coordinate plane and I plot -3, 4, I go -3 this direction and 1, 2, 3, 4 up. So I'm going to end up here, and we're going to connect him back to 0. And then from there, we have to make a triangle, and we always make bow ties and not hourglasses. So we're going to make our triangle looks like this, and that's going to be my right triangle that I have there. Okay, if I label the sides of that triangle, I have -3 here and I have 4 here. Okay, I don't have this side labeled, but we're going to have to find what that is. Some of you guys probably know already that that's going to be 5, but if you do the Pythagorean theorem, it's -3 squared plus 4 squared equals, we'll call it c squared. Okay, -3 when you square it is +9. 14 squared is 16, and then you have c squared. Okay, 19 plus 16 is 25, and if I take the square root of 25 is 5. So that's how you know that that is that value. I'm going to get rid of this question mark, and I'm going to put 5 in its spot. Okay. All right, and now angle theta. Angle theta will always be this angle that's inside right next to the origin. So this is the angle that I'm looking at, and then let's label our sides. So the opposite one would be 4. The hypotenuse is 5, of course, and then the adjacent is -3. Don't forget the negative on the 3. Don't forget the negative on the 3, okay? All right, so we do SOHCAHTOA, SOHCAHTOA if you need to write it out. So sine is opposite over hypotenuse, so sine is 4 over 5, okay, which means that cosecant is 5 over 4. We flip those around, all right? Cosine is adjacent over hypotenuse, so -3 over 5, which means secant is 5 over -3. And then tangent is opposite over adjacent, so 4 over -3, and then cotangent is -3 over 4, okay? So this is what you're trying to get to. That's a lot of parts, but it's kind of similar to the first problem that we did in this section, like 29 or whatever it was, okay? So there's that. The last 5 or 6 problems that we have are all the mixed review stuff. So this is going back to like linear functions and quadratic functions, and I think we do a little bit of, I don't know if we do some factoring. Yep, we do some factoring and that type of thing, okay? So 35 is writing an equation in slope-intercept form, okay? And we're writing the equation of a line, so we have a linear function. Slope-intercept form was y equals mx plus b, where m is the slope and b is the y-intercept, okay? So when we have the slope, we have 2 points that we're trying to find the slope of. And to find the slope when you're given 2 points, m is y2 minus y1 over x2 minus x1. That's how you find the slope between those 2 points, okay? So your second y-coordinate is this one, 9 minus 6 over 3 minus 2. So I have 3 minus 2. And 9 minus 6 is 3, and 3 minus 2 is 1. So my slope is 3 over 1, or just 3, okay? So now, for my formula, I know that this spot is a 3. Y equals 3x plus b. And then I need to find my b, okay? And to find b, I can either plug in... Is somebody at the door? No, she can't hear me. I think the wind's just blowing. To find the b, I can either plug in 2, 6 for x and y, or 3, 9. I'm just going to do the first one, 2, 6. It doesn't matter which one you choose. But just make sure that 6 is your y-coordinate and 2 is your x-coordinate. So when you plug them in, 6 goes in this spot and 2 goes in this spot, okay? So I have 6 equals 3 times 2 is also 6 plus b, okay? Then to get b by itself, I subtract the 6 over, and we find that b is 0. And the last thing I do is put it all back together. So y equals, we said my slope was 3, x plus, and b was 0. You can write your answer like this, or you can leave that 0 off and just write it as y equals 3x. That will work also, okay? That was 35. Back side, we're on the last page. Here we go. All right, 36. Write the equation of a line that is parallel to this function, okay? I'm going to write down 2 things over here on the side, and we're going to talk about parallel versus perpendicular, okay? Because on the test, I might give you perpendicular instead of parallel. I'm not really sure. I don't remember. But parallel versus perpendicular, it's not too much harder. If I'm doing parallel, I want to use the, I'm going to write this in a different color. I want to use the same slope. So the slope of this one, if the m is 3 over 2, I'm going to use the same slope. I'm going to use 3 over 2 as my slope. So this is the old m, and this is the new m. My old m was 3 over 2. My new m is going to be 3 over 2. Okay? But if it was perpendicular, I need to use a slope that is the negative reciprocal. Okay? And so if my old m was 3 over 2, because that's what it is from this function, then my new m is going to be the flip of that, which is negative 2/3. Okay? Hey dear.
Hi.
You have questions?
Yes.
Okay, I am recording four more problems. Give me just a second and just have a seat and I'll be with you in a second. Okay, so perpendicular, old versus new. So I have now, if I'm doing parallel, this one wants parallel, I'm going to use the new slope of -3/2. The only thing that I get rid of is the 9. You never use that 9 again. And then I just have to solve for what b is. So I'm going to do plus b, okay? In order to find b, I use this point, kind of like we did in the last example, to plug in, but just make sure that the -2 goes in for y and 4 goes in for x. So I have -2 equals 3/2 times 4 is 6 plus b. You can do that in your calculator if you want. We're going to subtract the 6 over, and b is -8. So I put it all back together and I get y equals 3/2x minus 8. And that is my linear function. Okay, that's parallel. But make sure perpendicular, if I give you perpendicular, you know that you flip the slope. Okay, 37, solve using any method. The two methods are substitution or elimination. elimination. I like elimination better. It doesn't really matter. You can do substitution if you want. This one's really easy to do substitution. If you solve for y, you can bump the y over and then plug it in. I don't care. I think I'm still going to do elimination though. Yeah, I'm still going to do elimination. So I'm going to eliminate the y's. And if this is -3y, this one has to be a positive 3y. Okay? And in order for that to be positive 3, I have to multiply by -3 in order for that to be positive. Okay? So I'm going to distribute my -3 through, and I've got -12x plus 3y equals, and if I do 0 times -3, that's still 0. Okay? Now I'm going to add these two together, and let's see, 6x minus 12x is -6x. The y's cancel out, and if they don't, I did something wrong, because that's what we're trying to do. Divide by -6, and we get x equals -2. Now, last thing, I still have to plug back in, and you can plug it into the top or the bottom, it doesn't really matter. I'm going to plug it into the top. -2 goes in for x, and I get 0. Okay, if we multiply, 4 times -2 is -8, and then we have to solve for y. I'm going to do this weird. I'm not going to add the 8 over, I'm going to add the y over, because then we will just get y equals -8. And last, we write the answer as -2, -8, and the reason why I care about that point is because these two lines, when I graph them, if I were to graph them, would cross at that point, -2, -8. So that's why I care about that. All right, 38, 39, these two are going to go real quick because this factoring is a difference of squares. You know it's a difference because it's minus, and you can take the square root of each of those pieces. And so when you do that, the square root of x squared is x. So I'm going to put that first. The square root of 64 is 8. I put that second. One of them is plus, one of them is minus. And then you have to set equal to 0. And so we're going to set, if we set x plus 8 equal to 0, that means x equals -8. And if we set x minus 8 equal to 0, x equals +8. Okay? So this right here, if we graph him, he's a parabola. And that just means he's crossing at -8 and +8. Those are my x-intercepts. Okay, 39, this is another factoring one where we're doing a simple trinomial. So we look at 8 and we say, what can you multiply to get -8, but when you add them, give you 7. And if you need to, go ahead and list them out. So -8 would be like a 1 and 8 combination or a 2 and 4 combination. The only way of getting 7 of some sort is 1 and 8. And if I want -7, it has to be a +1, -8. So I can group them. It'll be x plus 1 and x minus 8, and then I set each one equal to 0. So x equals -1 and x equals +8. And those are my two. So this is a parabola again if I graph it, and it's going to cross at -1 and 8 on the x-axis. Okay, simple trinomial, difference of squares. These are the only two factoring ones I'll give you. I won't give you a complex one, and I won't give you a greatest common factor. I won't do that. Okay. Last one, 40. We're taking the square root of these. This one is probably going to be one of the harder ones in the test, but write out all your work and you will keep everything straight. We're going to separate them into pieces. And so I'm doing 24, x to the 3rd, y to the 9th. This is one where we break it down. and we want to find a number that goes into 24 that you can take the square root of, which is 4 and 6, okay? And if I take the square root of 4, that becomes 2, and the square root of 6 doesn't come out nicely, so I leave it underneath, okay? X to the third, we talked about the other day about how you cannot take the square root of odd powers, but what I can do is I can hang one of those off and leave x squared underneath of here. And if I take the square root of x squared, it becomes x, and the square root of x just stays underneath, okay? Y to the 9th power, again, is an odd power, so I have to hang one of them off, and I have 8 underneath. I'm going to take the square root of x to the 8th power, which is x to the 4th, because when you have exponents, you're just dividing by 2. And then this one stays underneath, okay? And then I put them all back together. Wait a second. How did my x's become, or my y's become x's? Hold up. Just kidding. Y to the 4th y. There you go. Trying to put them all back together, and I have weird things. Okay, so now we put them all back together, and we look at the stuff on the outside. So 2xy to the 4th, and underneath is 6xy. Okay, I went through that last problem really fast, but if you need to pause or go back, I'll just leave this sitting up here. Go back through your packet, make sure that you have all of the things filled out. If you come on, let's see, Monday, did I say Monday? If you come on Monday with your packet not filled out, I can't help you. All right, make sure you have it filled out.